Slide 1, User Mode versus Kernel Mode. User Mode. In user mode, applications such as web browsers, word processors, and games run without direct access to hardware components like the CPU, memory, or disk. If these applications need to perform tasks like file storage, network communication, or accessing memory, they must request services from the operating system, OS, via system calls. This restriction prevents applications from crashing or damaging the entire system. Kernel mode. The kernel is the core of the operating system, running in kernel mode with full access to system resources. It manages process scheduling, memory allocation, device drivers, and security enforcement. Any crash in kernel mode can lead to a system-wide failure, blue screen or OS crash. Example: suppose you're editing a text file in Notepad. The application itself runs in user mode, but when you click Save, it makes a system call to request write permissions on the disk. The OS kernel processes this request in kernel mode and grants access accordingly. Slide 2. System calls. Definition: a system call is a controlled entry point that allows programs in user mode to request privileged actions from the kernel. Without system calls, applications cannot interact with system resources such as files, memory, or hardware. Types of system calls. 1. Process control, used for creating, executing, and terminating processes. Examples: fork, exit, exec, wait. 2. File management, handles file operations like opening, reading, writing, and closing files. Examples: open, read, write, close. 3. Device management, enables communication with hardware devices such as keyboards, printers, and hard drives. Examples: IOCTL, read, write. Example: C code, C copy edit. Ours include int main, write A1, hello, world, N, 14. Calls a system function to print text return. Here, write is a system call that interacts with the OS to display text on the screen. Real-world example: when you print a document, the printer driver makes a system call to send the file to the printer. Slide 3, Compiler versus Interpreter. Definition: compilers and interpreters are used to translate high-level programming languages into machine-readable code. Key differences: feature compiler interpreter. Execution translates entire code at once, translates line by line, speed faster, pre-compiled code, slower, real-time execution, error, handling shows all errors after compilation, stops at the first error. Examples: C, C++, compiled, Python, JavaScript, interpreted. Example: C, compiler-based, GCC mycode.c, generates.xe, runs directly, Python, interpreter-based, Python 3, mycode.py, runs immediately. Real-world example: compilers are used in applications that require high performance, like video games, operating systems, and databases. Interpreters are common in scripting languages like Python and JavaScript, which are used in web development and automation. Slide 4, Java Virtual Machine, JVM. What is JVM? The Java Virtual Machine, JVM, is a software-based execution environment that runs Java programs on any OS by converting bytecode into machine code. Java does not compile directly into machine code. Instead, it produces platform-independent bytecode. How JVM works: 1. javacode.java is compiled into bytecode.class. 2. The JVM reads bytecode and converts it into machine code. 3. Since each OS has its own JVM, Java runs on multiple platforms without modification. Why JVM is important? Platform independence. Java applications run on Windows, Mac, Linux, and Android without changes. Garbage collection. JVM automatically frees unused memory, preventing memory leaks. Security. Java runs in a sandbox environment, restricting unauthorized access to system resources. Example: a Java program compiled on Windows can run on Linux or Mac as long as the JVM is installed. Slide 5. Summary of key concepts. Quick recap: user mode versus kernel mode. User applications cannot access hardware directly, but kernel mode can. system calls. Programs request OS services like file access, memory management, and process control. Compiler versus interpreter. Compilers pre-translate entire code, while interpreters execute it line by line. JVM runs Java bytecode across different operating systems. Example. Question: why does Java need JVM while C doesn't? C compiles directly into machine code, which is OS specific. Java compiles to bytecode, requiring a JVM to execute it on different